Homework. Why is today a big day for you? You're going to write your first ever dreaded algebra to geometry proof. Okay? Get excited. Okay. But, how about this? I thought you did pretty well yesterday, but reminder, when you're trying to use the law of detachment and draw a conclusion, you try to draw a specific conclusion. I'm thinking of that midpoint one yesterday, where not a lot of you wrote the specific nature of it, okay? And then we had to fix it a little bit, okay? Bless you. So, reminder of what the law of detachment is. If P implies Q is true, and if they give you P, then what can you conclude? Q. Okay, that Q is true, exactly, okay? Now, how can this fall apart? A couple of ways. If the conditional is not true, then you can't use the law of detachment. Or, if they don't give you a true hypothesis, then you can't draw Q. Okay, so for example, I'm not going to do all of them. The first one, if a parallelogram has 4 congruent sides, that's my P, then the parallelogram is a rhombus. Is that true? Yeah, it is. Okay. Parallelogram WXYZ has 4 congruent sides. That means you're given P, therefore you can conclude Q, but you can't just say it's a rhombus. You would say parallelogram WXYZ is a rhombus. Okay? Whereas the second one, if X is greater than 7, absolute value X is greater than 7, even though that's a true conditional, you're not given the correct hypothesis, therefore you can't use the law of detachment. Okay? One more. If the light is flashing yellow, then you may drive with caution through the intersection. That is true. You're not supposed to slam on the brakes. You're supposed to drive through with caution. The light is flashing yellow. Conclusion, you may drive with caution through the intersection. Okay? So just try to be specific with your conclusions if you can draw one. Okay? Now that was the first one. Somebody want to remind us? Raise your hand. That was law of detachment. What is the law of syllogism? It is different. Elena.
It's whenever the conclusion of the first conditional is the same as the hypothesis of the second.
P implies Q. Q implies R. Therefore, what is true, everybody? P implies R. And I think I told you yesterday, you use this in your daily lives like all the time. You do a conditional, that leads to another, you connect them. It doesn't always work in life, it works in math, okay? Okay, but you have to consider, whether or not then they're connected. Okay? Cool. Okay, so I don't want to talk about that one. Should have been okay. I want to talk about these. Okay? I like these questions. Okay, assume the following statements are true. If it is a Monday, then John has practice. If it is a Wednesday, then Molly plays piano. If John has practice, then he gets home late. Robert only goes to church on Sunday. It seems kind of random. And then E, it is a Monday. Okay, you're supposed to decide if it must be true, may be true, or is not true. I actually don't think they asked you to explain. Did they? I'm going to give you a little heads up. When you take your Chapter 2 test, it's going to ask you to explain. So if you didn't, that's fine, but you're going to have to in the future. Okay, so why does John has practice must be true? Why does that have to be true? Okay, it has to be. Grace?
Because it states that in the thing A, that on Monday you have practice.
And it also states?
That is Monday.
Okay. You have to couple these statements together. E and A. E says it is Monday, and it says if it's Monday, John has practice. No ifs, ands, or buts. Okay, that is your explanation. Okay, so those statements go together. Molly plays piano today. Anybody want to tell me why they say it might be true? Might be true? Kennedy?
Because it doesn't say that she only plays on Wednesday.
It doesn't say what?
That she only plays on
It doesn't say she only plays on Wednesday. So we know it's Monday, okay, and we know that if it's Wednesday she plays piano. We don't know she doesn't play on Mondays. We just know she definitely plays on Wednesdays. And then the last one, Robert is going to church today. This can't be true because of statement E, what does it tell you? It's Monday, and it goes with statement E. Okay? So questions like this, usually they're not too bad, but you will have to explain kind of like I did and you did right there on your next test. You're not just going to be able to say always sometimes or never. Okay? Cool. Good times. I know I found this. There's actually the Brain Rock cakes out there. It's a little bit terrifying. Okay, good times. Okay, so let's go to today. I don't know how long it's going to take you to devise your first proof. Sometimes it goes really smoothly, and sometimes it's like a big clunker. So I want to make sure we leave enough time. Okay, I think you've got pretty much a full page of warm-ups there. Go ahead, talk about them. Full page.
Oh, yeah.
Whole first page.
Wait, would this be?
Are these still biceps?
I guess so.
All right, so. Wait, so it's equals to x
You don't have to solve 5 and 6. You can, but you don't have to.
It'd be 7.
Take a look at the first 3. Please watch your notation. A. The bisector is ray OB. You can't just write OB. Ray OB. It is a ray. We got a point here and then right there. The other one shouldn't be too bad. Okay, but your notation does matter. Okay, you don't have to solve 5 and 6 if you don't want to. You can. And then 7 is just drawn. Try not to look those up because you will need to know those properties. Finish up that matching now. Nah, you don't have to solve these. All right, finish up that match. Okay, now, I know how this goes between pre-algebra, algebra, and then you keep going. At some point, we show the properties, and we usually tell them, it's okay if you can't quite remember them. That's actually not going to be the case here. You have to finally keep them all straight. So if you've never been able to get the difference down between associative and commutative, this needs to be the time. Okay? I've said it before because I've taught all those classes too, and I'm like, it's okay if you don't know them, we move on. No, you need to know the difference. This is the time. Okay? What's this first guy right here? 3 plus 7 equals 7 plus 3. Ronan, what is that one?
That's the commutative property addition.
Yes, it is commutative, not commutative, although truthfully, it's close enough. So if that's where we flip the order and it's addition, this appears to be flipping the order and it's multiplication. So what's that next one going to be? Commutative property of multiplication. You do need the full name. Okay. Now the associative is the one that gets people. Okay. It's just you're associating the parentheses with different things. So here it's with 5 and x. Here it's with 2 and 5. Here it's with 9 and 53. Here it's with 1 and 9. Then you just match it up. So this is associative multiplication. Okay. And then this is associative addition. Okay. Nothing too crazy, but you're going to see today as you justify everything that you do, and the name of the game today is going to be justify. You need to justify correctly. Okay, so kind of, if you've always struggled with those, this is the time to kind of rein that in a little bit and then have it, okay? Cool. So, what I want you to do, and this is going to seem silly, I want you to, as a table, look at this solving of an equation. You don't need to write anything. And I want you to talk about, if I ask you to justify every single step, what would you say? Go ahead. Don't write it, just talk about it. Each and every line. Each and every line.
And then after that, you divide like terms. And then after that, you divide. And you answer.
Okay, now, I don't doubt, this is going to be the frustrating part for a lot of you. I don't doubt your ability to follow this. I don't doubt your ability to follow anything we talk about today. I worry that some of you are going to resist saying, why do I have to justify it? Everything has to be justified when you're talking proofs, okay? Actually, the first line might have been the one that you didn't know what to say for, but I needed something for this. It's actually not that bad. No, I mean, nope. I didn't do anything in the first line. I'm right here. Okay, so anybody know what we would say? You would only know this if you've seen it before, like a geometry proof or anything. It's given. You're going to get used to that. Why am I showing this to you? Because every step, every proof you write, every single one, guess what your first step is going to be every time? The given. Okay? That's 3 points. If this were 5 points, 1 point would just be you acknowledging that that's what's given. Okay? Now we start talking about it. And again, I don't doubt your ability to know what's going on, but you're going to have to be specific. So what they do here?
Distribute.
Nope, that's the distributed property. Okay, distribute. What they do here? Combine like terms. Okay, so simplify, but I would actually rather write combine like terms. How about here? That's not an actual mathematical property. What are they doing to isolate the variable? Adding 1 to each side. That has a name, okay, which we'll get to in a moment. You don't have to write it. That's called the addition property of equality. Isolate the variable is not a mathematical property. That's a concept. That's what you're doing. Okay? They're adding 1 to each side. That's called the addition property of equality. We'll get there in a couple of minutes. You actually learned that when you did it with Miss James. Okay? That lands them what here? So that's where they simplify. Simplify. And then what's this next step here? The dividing each side by -5, so guess what we're going to call it? The division property of equality, and then they simplify. Okay? Now, you might not have to write simplify every time, okay? But that does justify each and every line. So I know a lot of you are going to get annoyed by this, but we're going to be focusing a lot on this today. This is non-negotiable, okay? I don't doubt your ability to do this and follow it. Same with all the concepts, okay? But doing this is going to be a huge part of it, okay? So we're actually going to start by filling in that chart. Okay, why don't you just take a moment as a group and see if you can fill in all the blanks. This should not take you super long. See if you can fill in all the blanks on that chart. Fill in all the blanks on the chart. You actually learned this with Miss James, but then you didn't spend a lot of time on it. You just went to solve it. Did you say it's on the key status?
No, they like
On the formula sheet.
I was
I know.
scared that I didn't know that, but it was like all on the formula.
This shouldn't take you super long. It's just filling in letters. Give me a hand up when you're done. Hand up when you're done with the whole chart. It shouldn't take you super long. Stand up when you're done. Come on, you gotta keep it up for people as we finish, and it's okay. If you're not done, you should be close. Should be close. Alright, good enough. Okay, so a couple of these we've definitely talked about, a couple of them we have not. Okay, now when you talk about subtraction, addition, division, and multiplication properties of equality, you 100% went over those with Miss James when you started learning. You did. But then after you learned them, you never talked about them again. You just solved equations. Okay? Cece brought up a good point. It was on the formula sheet for the Keystone scale separate. I can't have that. No. Okay, it's actually on the Keystones. If you looked at the formula sheet last year, you didn't actually need to know them, but they might have thrown a multiple choice question at you that said, which property are they using? Why do you suddenly need to be able to quote them now? They're the justification. So you do have to not only understand them, you have to know them and be able to recall them by name. They shouldn't be too bad. Okay, let's go addition. If A equals B, A plus C is equal to B plus C. What does that mean? You can add whatever you want to both sides as long as you're consistent. You already knew that, but now you have to be able to quote it by its name, the addition property of equality. Subtraction is very similar. If A equals B, A minus C equals B minus C. Let's go to multiplication. If A equals B, A times C is also equal to B times C. And the division one, they actually gave it to you, but what is C not allowed to equal? 0. Okay, so that shouldn't be too bad. Okay, now let's go to some of the other ones. We actually did the transitive one yesterday. We didn't call it the transitive. We called it the law syllogism. It's exactly the same. If A equals B and B equals C, good, maybe make a note right there. That is the law of syllogism. It's the same thing. Transitive property, law syllogism, same thing. Okay?
Instead of writing like transitive on the test code,
We're going to talk about that. They're different. They're like slightly different. Okay? Law syllogism, we're typically talking about conditionals. These are equations. Okay, good question. Okay, symmetric. If A equals B, sounds silly, but you know what? Some of you will roll your eyes at the silly stuff, and then you won't be able to recall it, and you'll lose points. Like you have to state the silly stuff out loud, okay? Speaking of silly stuff, the reflexive property. Yeah. Now you're probably wondering, in what world would I ever need to state that? This world, geometry. Not so much today, but still. And finally, if A equals B, then B can replace A in any equation. That is substitution. You will have to know and be able to quote all of those as you're constructing proofs. Hello? I do. Yep. Mm-hmm. So you're good, yeah. Okay. Then finally, to round this out, not in the chart because it's slightly different, we have the distributive property. You should 100% know this. A times B plus C is equal to AB plus AC, and B minus C times A is equal to AB minus AC. Usually we just call it the distributive property. Some people call it over addition or over subtraction. I think that's unnecessary. I'm fine if you just call it the distributive property. Okay? So, all of those on that page, that whole page, they're going to come up. You actually know all of them. The hard part's going to be recalling them as justification for the stuff you're doing. Okay, Jack, question? That's about it. Okay? Cool. So we're going to look at some of our first proofs, and it's going to seem a little bit like, how do you begin? Just stay with me, okay? Logically, you can follow everything, but the nitty-gritty takes some time to develop. Okay, given that diagram, they want the value of x. I don't doubt your ability to find x. I worry about this. We're going to have to justify each and every step. Okay, what are we given? Ray, AB, one say bisects angle RAN. That is helpful. I do not want you jumping right into the algebra right now. I want you to decide which of these three statements do we know from the given information. I want you to stand up when you've got your choice. Which of those three can we know for sure based on the given? I want you to stand up when you've got your choice. Okay, how about And I want you to sit down when I say your choice. Okay? Who wants angle RAN is obtuse? Okay, good. You can't do that. Who wants angle RAB is congruent to angle RAB? Good job. So nobody wants this one. Perfect. Okay? So again, if you were solving this, I don't doubt that you would know what to do with the algebra. Okay? What would you do with just the algebra? You would say I'm equal, but here's the problem. You have to like justify everything, and that's actually what we're going to do. So we're going to start talking about this now. Step one, I need you to write this. We're going to state that the measure of angle RAB is equal to the measure of angle NAB. But what's the reason?
Pardon the interruption. At this time, the students that are attending the Remake Learning Expo at the Children's Museum, please report to the main lobby. Again, students that are attending the Remake Learning Expo, please report to the main lobby.
What's the reason? Cam? It's not given.
We're given that it bisects.
I know.
So.
And this is annoying, I know. Sometimes math is annoying. Got it?
Would it be the transit? The transit?
No, everybody's guessing now.
Is it a given?
Need more though. We know it's given. How do you know you're allowed to do this? Definition of angle bisector. I need you to write that down. This is where proofs get sticky. We're not given that those are equal to each other. We're given that it bisects. So why are we allowed to make this bold claim, which all of you made? It's the definition of an angle bisector. Okay? Next, now we can state x is equal to 2x minus 75, which we would have done earlier, but we couldn't justify all the steps. I have to justify that step too. Anybody want to take a crack at this one? Grace? It is substitution. Grace! I'm substituting x in for what, everybody? The measure of angle RAB, and we're substituting, come on, tell me, 2x minus 75 in for that particular angle. Nice job. Now solving this, I don't think would be too bad. That's my next line. Okay, I'm going to add 75 to each side. Justification? You just filled out all these charts. Just tell me if you know. The addition property of equality, which you have to write, addition property equality. If you abbreviate it like I did, that's fine. What's next? Subtract x from each side, which lands you at 75 equals x. What justified that? Subtraction property of equality. Finally, x, x equals 75. Symmetric property of equality. Oh, how fun. How fun. We justified each and every single step. Gotta do it. Okay? Now, the hard part with proofs, there's two different stages. For some of you, it's just, I don't want to write it down. Well, if you don't want to write it down, you're going to get crushed on these. If it's like 8 points, you'll get like 2 out of 8. That's not going to be the hard part for most of you. The hard part for a lot of them is knowing how to begin. You'll get better at that. Okay? It can be very intimidating to look at a proof and just feel like you're pulling it out of thin air. I get that. Okay? But it takes a little time. Okay? So that's why they started you with this. They started you with which statement can you get from the given. The given was that AB bisects that. Notice we had to pull from our background knowledge. We had to know what an angle bisector was. Anytime you use something you know about something, it's going to be a definition. Okay, it's a definition angle bisector. The rest was right off that page. The algebra is not hard. The algebra is rarely going to be difficult for you in these. It's going to be justifying everything. Okay? So we're going to look at this guy right here. Okay? And we're going to kind of walk through this proof yet again. Okay? We need to find the value of x, and we have to justify each step. Okay? So what do you notice about that diagram? Given that angle AOM and COM form a linear pair. So if I had to justify every step and I didn't feel like doing it, here's what I would do. I would start thinking about all the background knowledge I have when I read this given. Okay, and what should be your big one? Linear pairs are what? They're supplementary and they're also adjacent. Once I know all the knowledge I have, I can start to construct the proof. Okay, so we're going to justify all of them. First step I would give you, the measure of angle AOM plus the measure of angle MOC is 180. Let's see if we can crack it this time now. Justification. Layla. Definition of a linear pair. Nice job. That's the definition of a linear pair. See if you can finish the rest of the proof as a table now. Go ahead. See how you do. See how you do. See if you can finish the rest of the proof. We'll clean it up after.
So it's combining.
What are you doing?
I don't like
It should also be numbered. The number of you that aren't numbering your statements are going to get lost in your work. Some of you are making some good progress. Anybody that finished want to tell me how many steps it was? 5. Should be 5. Should be 5. Okay, so Layla got us kicked off with definition of linear pair. That looks good to me. I really think you should number your statements, not only for your own benefit, but if you get lost in the shuffle, it's hard to know where to go back. So that's why I put 1 here. That's going to be required in a second. Okay, anybody want to tell me what they said for step 2? What did you say for step 2? Benji?
2x plus 30 plus x equals 180 and substitution.
That's substitution. Now, it's technically called the substitution principle. I'm fine if you just write down substitution. Okay, that is the full name. But if you just write substitution, that is good for me. Okay, who's got the next step? Cora.
I had 3x plus 30 equals 180, which is combining like terms.
Combining like terms. Pretty good. Okay, what we got next? Elena?
I have 3x plus 30 minus 30 equals 180 minus 30.
Okay, so let's talk about that. You do not need to write the minus 30 unless you feel like it. I personally don't think that any of you in here do. I'm not going to tell you you can't. I would just jump right from 3x plus 30 equals 180 to 3x equals 150. Okay? What's the justification for that though, everybody? Subtraction, property of equality. You do have to say of equality. You'll see why in a moment. Okay? And I got one more step. X equals 50. What's that guy? Division, property, equality. You'll get the hang of it. You will get the hang of it. Okay? And then you'll get a flow for kind of what things are. Okay? Questions about that one? Okay. Cool. So why do you need to state equality? Because sometimes it's not equality, sometimes it's congruence. Remember, angles are not equal. Angles are congruent. measures of angles are equal. Okay, so we also have a couple properties of congruence we need to fill in at the bottom. Reflexive, angle A is congruent to angle A. Symmetric, if angle A is congruent to angle B, then B is congruent to angle A, and then you have your transitive property. But it does matter. I need to know if it's equality or congruence. I will let you abbreviate them a little bit, which we'll talk about. But you can't use equality when it's congruence and vice versa. Okay? Any questions about that? So Sawyer asked a good question earlier before he got called out, which I'm sure was to win an award, so you're good. Great. Perfect. Okay? He asked, can we say this versus the law syllogism? They're the same idea. They're not actually the same thing. The law syllogism deals exclusively with conditionals. The transitive property deals with equations and congruence. Okay, so keep those things straight. But they say the same kind of thing. The law syllogism is kind of like if this leads to that and that leads to the other, then they're connected. Okay, but the transitive properties of congruence and equality, they're more dealing with like equations and values right there. My gosh, what is going on today? Is the bass going to drop? I'm trying to see if it syncs up with this. It can't be Morse code. It's the same thing every single time. It could turn into Kahoot music like pretty fast. Do you know what I mean? Actually, no, it's the me music. It is real loud, yeah. Okay. Well, we're gonna keep going. So, completing the statements, if angle P is congruent to angle R, then angle R is congruent to angle P. And if angle X is congruent to angle N, and angle blank is congruent to angle Y, then angle X is congruent to angle Y. What goes in here? Angle. Okay. Good. Cool. And again, just picking out the difference between them. Okay, we're naming the property of equality or property of congruence. Okay, that makes the first statement turn into the second one. And again, it's going to seem silly, but wording really matters. So 2x plus 9 equals 19. How do we get to 2x equals 10? We subtract 9 from each side. It's an equation, so guess what this guy is? Subtraction, property, equality. I'm fine if you want to abbreviate the equality with the equal sign. I didn't get a notification or anything, so. Angle O is congruent to angle W. Angle W is congruent to angle L. Therefore, angle O is congruent to angle L. What is we going to call this? Word for word. This is the what? Transitive property, congruence. Same thing. If you want to do the congruent symbol instead of writing out congruent, that's fine with me. I know it's a lot of writing. Moxley's been waiting years for this. Pumped. Okay? I know. But I'll let you abbreviate in a couple spots. Now you can't abbreviate everything because I'm not sure what you're talking about. Okay, but you can abbreviate equality and congruence like this. And the last one, angle N equals the measure of angle N equals the measure of angle E. Measure of angle E equals the measure of angle N. Symmetric property, equality. Equality. Okay? You may never know. It's a little too soon for the ghost to be visiting. Cool. All right, now it's time. Now you're actually going to write your first big kid proof. It's going to be great. Actually, this first one's not too bad. We're only going to do one. A proof is a convincing argument that uses deductive reasoning. Okay, you did a great job with the deductive reasoning yesterday. Remember, last week was induction. I give you a pattern, you figure it out, you go forward. Deduction is, I just give you a whole bunch of statements, and you draw a conclusion from the statements. That's what a proof is. It logically shows why a conjecture is true. Okay? What we're going to work on, the dreaded 2-column proof. If you know anybody that's taken geometry at all, and you tell them, hey, we did a 2-column proof, they're going to be like, have fun with that. They're actually not that bad. I think for a lot of students, the most intimidating part is they don't always know how to begin. That's just something you get better at as we go. So let's kind of like this. Okay, you're given a statement, almost always a diagram, almost always, asked to prove something. You'll list your statements on the left side, your reasons on the right. You will notice they're numbered. They do need to be numbered. That's why we should just get into the habit of it. The first statement is always going to be the given, and guess what the last statement is always going to be? What they ask you to prove. Okay, so the logic of that makes sense. The hard part is I'm going to throw some at you in the coming days, and you're going to be like, I don't know how to begin. That's a normal struggle. Okay, it's something you get a little bit better at. Okay, and the reasons are going to be definitions, theorems, all the kind of stuff we know. You do need proof. The hard part for a lot of you is going to be you're going to look at it and you're going to think, well, it's obvious. Yeah, that's a 0 out of 10 or a 0 out of 8. There is nothing obvious. Even things that you believe to be clear and true have to be justified. Okay, but you'll get there. Okay, so that's actually what you're going to be asked to prove right there. That diagram, given that the measure of angle 1 is equal to the measure of angle 3, what are they asking you to prove? The measure of angle AEC is congruent to the measure of angle DEB. My advice for students before they begin a proof is to look at the diagram and ask yourself, do you believe what they're asking you to prove? So they're given 1 and 3 are congruent, and they're asking you to prove that AEC is the same as what? DEB? Do you sort of buy what they're selling? That is good. Okay, they're not going to ask you to prove something that's not true, but the reason I think it's helpful is because then you can start to formulate a plan of attack. Okay? So without talking reasons, without talking statements, have a conversation with somebody around you. How are you going to get yourself to build some kind of argument to get this? Don't write anything. Just talk. What do you see in the diagram that will maybe lead you to a conclusion? Alright, so here's what you're going to get. The first couple, not too bad because everybody's looking ahead, and I really wouldn't because you'll miss stuff. Sometimes they'll actually give you the statements and just ask for the reasons. Sometimes they'll give you the reasons and ask for the statements. Eventually, you're not going to be given anything outside of this information, and you'll fill all this in on your own. Okay, that's baby steps. So you will notice at the bottom, you have a 2-column proof, your statements on the left, your reasons on the right. Okay, the first line is blank. It shouldn't be too hard to fill in. Okay, CC. Okay, but given is my reason. What are we putting here for our statement? Come on. Measure of angle 1 equals measure of angle 3, and your reason is given. If this is a 5-point question, everybody should get 1 out of 5 because you'll get a point for just writing down the given. Okay? Now you'll notice yours, they gave you the statements, didn't they? Sometimes they'll do that and they'll ask for the reasons. Sometimes your homework will give you the reasons and ask you for the statements. Eventually it's all going to be blank and you have to construct it from scratch. Okay? What's the next statement that they give you? Measure of angle 2 is equal to the measure of angle 2. Silly, but necessary. What's our reason for that? Ava. Say the whole thing. Reflexive property of equality. You have to state of equality. It's not congruence. Okay?
We just look right reflexive.
Reflexive property of equality. Reflexive property of equality. Okay? Why in the world would they need to state that? Well, because watch what they do next. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. Let me look at the diagram first. So they're claiming that the measure of angle 1 plus the measure of angle 2, say yellow one, is equal to the measure of angle 3 plus that 2. That kind of makes sense. Okay? What would you say for a reason for that? You need justification. Tomlin. That's not the transitive property. Jazzy. Oh, look at what we're doing. We're adding the same thing to each side. Addition property of equality. Why do we have to state that measure of angle 2 is equal to measure of 2 so we can properly add it to each side? Otherwise, we wouldn't have been able to do that. Okay? This next one's probably the hardest one. Okay? They're saying that the measure of angle A. They're saying that the measure of angle AEC is equal to the measure of angle DEB. Okay? Caleb. It's not substitution. Ronan.
Is it transitive?
He is not transitive. It's not on anything that we did today. It's easy. Huh? What? It's not in your classwork at all today. It's something we did a long time ago. That's why you're going to hate it. It's called the angle addition postulate. Well, I did postulates with you a long time ago. The angle addition postulate stated that angle 1 plus angle 2 is this whole angle. Angle 2 plus angle 3 is this whole angle. Now you might be wondering, how in the world was I supposed to recall that? You weren't. I didn't anticipate anybody just opening their mouth and saying angle addition postulate. That's why these take practice. So not everything that we do in the proofs is contained in today's classwork. We're also not done with this proof yet. Okay? Not everything is contained. So if I give you a postulate, a theorem, a definition, you know what the hardest part about the entire class is? You kind of need to know them all. And that's not just me telling you that. Anybody that's taken the class will tell you, you got to know your definitions, your theorems, your postulates, okay? But that is a postulate. When I showed it to you a couple weeks ago, this is chapter 1, a lot of you rolled your eyes. I said angle 1 plus angle 2 is the whole thing. Angle 2 plus angle 3 is this whole thing. I don't know if anybody remembers what a postulate is. It doesn't need to be proven. A postulate is a given, it's a truth. We had another name for it. Does anybody remember what we called it? An axiom. Nice job. Okay? So, we ended up here. We're so close to being done. Last thing I write down is QED.
It's already written for
Oh, it's already there for you? Anybody know what QED is? No one knows what QED is?
Does the E stand for equation?
It does not stand for equation. Okay?
It stands for equals.
No.
It's only quality.
It's Latin. It'll come up on Monday. It'll come up on Monday. Okay?
Quantity equality.
If you're really super duper curious, you can look it up, and it is going to come up Monday. Now, wait, I want to go back to this proof. Wait. Okay. So, I thought you did a pretty good job with these. Where are we at? These. Okay? These, I think you're like, okay, I kind of get a feel for what it is. Okay, I know when to use them. I know when to state equality versus congruence. That is cool. Okay, the problem is going to be when you have to start doing the following things. Spitting out definitions. Like, definitions matter a lot. Okay? And then occasionally, you're going to have to pull out, where was that last one right there? I think it was step 4. You're going to have to pull out some of these postulates, theorems. So when I tell you, when we fill in a definition or a theorem or a postulate in class, we're not doing it just to fill time. It's going to come up at some point in proof, and you're going to have to be able to recall it. That's why we slow walk you through the proofs. So when you get to your homework, they'll usually give you this, that, or a mixture. That's good. But eventually, Once you start to follow the flow of these things, you're gonna have to build them entirely from scratch. That's where it's gonna get tough. Okay, but one step at a time. Okay? Please start looking at this. And make sure your two columns are clear. We'll talk about QED on Monday. Oh no.
No, but isn't that like?
QED.
I was